What'd you do? What'd you do first?
So I made the 4 2 squared.
Yes. And again, that feels weird the first time you do it, because you're like, why am I replacing 4 with 2 squared? That seems a little bit weird. So, Megan, answer that question. Why would you replace a perfectly good 4 with 2 squared?
So that is like equal to each other.
Good. So now the bases are equal to each other. So 2 to the 2x plus 2 equals 2 to the 4th. Once you have a common base, you can set the exponents equal to each other. And if I subtract 2 and divide by 2, I get x equals 1.
I just made the 2 a 4.
You just made the 2 a 4. What do you mean?
4 squared plus 2 to the 4th is 16.
Okay, 2 to the 4th is 16. And then you replace 16 with 4 squared?
Yeah.
That would work. And then you would set those exponents equal to each other. Yep, and you would get x equals 1. That would work. That way, I don't know that way would always work, but it worked here, and that's perfectly okay. Okay, that's review. We've done that before. That was even on the last test. Type 4 we've not done before. So, exponential when the bases can't be made equal. Well, I bet you know what to do first on this. Joaquin, what would you do first on that equation, even if you don't know how to do all of it? Joaquin, you awake back there? Kinda. What would you do first on this equation? Minus 3. Yeah. So maybe we don't know where this is headed, but we could at least subtract 3 and get 5 to the x by itself. Okay. I'm going to show 2 different ways to work this problem. I'll do the way I like first, and then I'll do the other way second, and you can pick whichever way you like. Isolate the base with the power. So we did that already. We didn't even talk about the rule. Just Joaquin figured out that it's probably best to get the 3 out of the way. So yes, do that. Use log or natural log on both sides, and then with the power property of logs. So I'm going to log both sides. Actually, I'm going to set this up as option 1 and option 2. Yeah, this is new. You probably should be paying attention now. So option 1 is my favorite, but it doesn't have to be your favorite. I'm going to natural log both sides. So natural log of 5 to the x equals natural log of 80. And maybe that feels weird because you're like, wait a minute, that makes things more complicated.
You mean 77?
I do mean 77. Thank you. Yes, it makes it more complicated. It puts a natural log on both sides. But do you know what this power property of logs is referring to? If I highlight that x, does that remind you of something we could do with that x? We could put the x out front. And so that's why we like to log both sides, because that exponent is now a coefficient. And natural log of 5 and natural log of 77, I don't know what they are, but the calculator does. So what could I do to solve for x? Divide by natural log of 5. Thank you. So natural log 77. Be careful, make sure you close parentheses, because if you just hit divide right there, you're going to be doing 77 divided by natural log 5 and then taking the natural log. That's not what we want. So natural log 77 divided by natural log 5, 2.699. And you don't have to check these, but they're pretty easy to check, because 5 to that answer, 5 raised to that answer, plus 3, that's supposed to be 80, and it is. So you don't have to check those, but it's usually pretty easy to plug it right back in, and especially since you have a calculator on these, to verify that it's right. Goodness, do we even want to worry about option 2?
No.
Yeah, because if you do option 2, I got to teach you something else. Let's just stick with option 1. It's the easiest. Because when you log both sides, that exponent, that power property, allows the x to move down front. And that's what sort of unlocks the rest of the problem. So if there's a variable in the exponent, you can log both sides and get it out of the exponent and into the front. Okay, next page. The only two you have to do on the next page are 7 and 8. So why don't you do those real quick, and then we'll move on to the next thing. Now, maybe this feels a little out of order because those are that type 3 problem. You don't have to log both sides. You don't need a calculator.
Can you like get rid of the negative on the exponent?
Sort of. So that's a different way to approach this. But so what would the left-hand side be then if you got rid of the negative on the exponent? I could flip it. So it's not. Yeah, that works. That's a different way than I was going to go. But if you use the negative to flip that, you get 4 to the x. I was just always thinking like rewrite 1/4 as 4 to the negative 1, and then the negative 1 times negative x becomes positive x. So that way, your way is better. I was going to do it, the formulaic way, but you seeing that the negative would flip it is better. Adeline, how about 16? How can I rewrite that? 4 squared, and then this became a really easy problem. If 4 to the x equals 4 to the 2, well, I'm pretty sure x has to be 2.
If the rewriting 16 and just know 4 to
And just see 4 to the x equals 16, yeah, I would think that's obvious enough to be like, oh, it's got to be 2. Definitely. In fact, on number 8, Marina, what did you do on number 8?
I changed 81 to 9 squared.
Good. I didn't even want to point out which side to work on because I don't think you need to work on the left-hand side. Change the 81 to 9 squared, and then you got 3x plus 1 equals 2. So 3x equals 1, and x equals 1/3. Okay, done with that worksheet, including the stuff on the back. It's lots more practice, but today there's a gazillion problems, and we are not coming close to working all of them. In fact, the next worksheet, students hate this. Well, they love and hate this instruction. Multiples of 3. Why would you like that instruction on a worksheet? You're only doing a third of the worksheet. Why would that be an annoying instruction on the worksheet? You got to figure out which ones are multiples of 3. So you got to do math in order to do math. It's a little trick we pull on you there. I mean, it's not hard. 3, 6, 9, 12, etc. Well, I know. So Jackson's already peeked ahead. How many questions are there on this worksheet? 83. But if you divide that by 3, it's not so bad. 27. Okay? It's not insane. We're going to do a bunch together. Some of them are from the multiples of 3 and some are not. Let's make sure we're in the right section here with calculator on this first section. So let's look at number 7. Times 2. 4 to the x equals 40. Okay, now this is with calculator, so I'm kind of thinking already that rewriting the bases is probably not gonna be possible, right? I can't rewrite 40 as 4 to some power. I guess I could write it as 4 times 10, but that doesn't really help me. So what should I do next on this problem?
Natural.
Yeah, let's natural log both sides. Or log both sides, it works either way. I'm just more used to using natural log. But either log button on the calculator would work. D'Entrée, 2 questions with sort of the same answer. Why did I natural log both sides, and what does that mean I would do next for this problem? Perfect. The reason we did that was so we could move the exponent down front. So x natural log 4 equals natural log 40. So natural log 40 over natural log 4. Whatever the calculator tells me that is. Careful, it's not the same as natural log of 10, so don't try to shortcut things here. 2.661. And just to convince you that you can use log or natural log, log 40 divided by log 4 is the same thing. So either one is fine if you have a preference. Okay, skipping ahead. Let's look at number 15. And that would be a multiple of 3, so there you go. Liam, thoughts on what we should do first on number 15? I've got a variable in the exponent. I don't like a variable in the exponent because there's not much I can do with it there. I'd like to get that variable out of the exponent. So if I natural log both sides, then that exponent can come down front. Now this one's a little bit weirder, harder than the last one because it's not just an x, it's an x plus 2, but it's the same process. Like I just got to bring that whole x plus 2 chunk down to the front. So my answer is starting to look weird, but that's okay. I'm starting to get x by itself. Ryan, thoughts on what we should do next? Good. Divide both sides by natural log of 5. I suppose you could distribute the natural log 5, but then you're going to be dealing with natural log 5 the rest of the way. It would be easier if you would just divide both sides by natural log of 5. So the right side's looking kind of crazy, but that's okay. The left side is getting cleaned up. Cody, the right side looks weird, but if you had x plus 2 equals something, what would you do to get x by itself? Subtract 2. So let's do that. Natural log 500 over natural log of 5 minus 2. These are more good problems where don't grab the calculator to the end, right? Because I don't really care what natural log of 500 over natural log of 5 is. I don't want to, or natural log 500. Don't put that in the calculator. Wait till you solve for x, then grab the calculator. Natural log 500 divided by natural log 5 minus 2. There's my answer. And again, checking is easy because you have a calculator and you've got the thing you want to plug in, like right there in the calculator. So 5 to the answer plus 2. That's supposed to give me 500, and it did, so I know I got it right. Again, you don't have to check them, but it's super easy to check them. So if you do one that's got a bunch of steps and you're not sure you did everything right, it's really easy to make sure you got the right answer. Okay, now we're going to start jumping around a little bit in terms of types of problems. Looking at 17, Carson, what do you think we should do on 17? We've done this type of problem before, but it's not today's type of problem. What could I do on the right-hand side here?
Oh, divide?
Yes. So what would I get on the right-hand side?
Log 4, 16 over 3.
Yep.
15 divided by 3.
And I'm going to do the math for you there. I'm pretty sure Carson knows it's 5. So log base 4 of x equals log base 4 of 5. This is another one of those where even if you have no idea what log base 4 means, I'm pretty sure x has to be 5 for this thing to work. So this worksheet starts jumping around a little bit on us. Turn the page. Let's keep doing some. Now let's do 24. And is 24 a multiple of 3? Let's do a little multiple of 3 check here.
Yes.
Yeah, so this is one that you would be doing later. Nick, what would we do first? What do you think?
Minus 1.
Good. Carlo, what would we do next after we subtract the 1? Divide by 3. Ooh, is 94 divisible by 3? We're still in the calculator section, so if we weren't sure we could type it in, but I'll just leave it as 94 over 3. E to the x equals 94 over 3. That looks weird. Preston, any idea what we should do next on this one?
Natural log.
Perfect. It's natural log both sides. And this turns out to be one that's nicer than the others. Reese, why did Preston choose to natural log both sides? Like, what can we do next?
So move the x to the coefficient.
Good. Move that x as the coefficient. And you've got a calculator, so I suppose you could divide both sides by natural log of e, but it would be better if you were kind of on your toes and realized the natural log of e is 1, so this really is a nice one. I mean, maybe that's too kind to that problem. Natural log of 94 over 3, 3.445. And again, super easy to check. I'm going to stop checking in a moment, but they're so easy, it's worth it, I think. 3e to the answer plus 1 is supposed to be 95, and it is, so I know I got it right. It's nice when you have the calculator. Let's do 27. And for some reason, I'm going to put 3 stars on 27. No, it's not a bonus, but you're thinking in the right direction. Where would a bonus show up? On a test.
Oh, this is on the test.
Oh, you guys are so smart. So smart. That's why this is an advanced class.
This is specifically.
I mean, be careful. It's not like those numbers, but this type of problem. Don't get too excited that like you're going to see that exact problem there. Something is weird about this one, though, so I don't want to pull a popsicle stick because we have not done one quite like this. Any thoughts on what we could do with this one?
You should move the 10 to the right or divide. How do we know?
Well, you could move the 10, you could divide, but when you divide, you lose solutions when you divide by things that have x's in them. So we would lose answers if we did that.
Can you just throw a natural log on it?
No, even if we move the 10 e to the x over, the natural logging this wouldn't really work very well. Any other thoughts? The dividing is kind of in the right direction here. I will enlighten you. Both of those terms have an e to the x on them.
X equals 2.
So what can we do if like two terms have the same thing in them? You could like factor it out. So let's factor out e to the x. And now, I don't mind picking on people now. Cooper, what would be left if I factor out e to the x?
Oh, 5x minus 10.
Which means I could have factored out a 5 as well, but the 5 doesn't matter as much. Okay, I have two things multiplied together to be 0. This is the step that that means either one of them is 0. So e to the x equals 0, or 5x minus 10 equals 0. Right, so that one's easy, x equals 2. On the other one, is there some power where I could go e to some power equals 0?
No, there's no.
No, that's not possible.
Unless e was 0.
I suppose if you weren't sure, you could natural log both sides. And if you typed in natural log of 0, your calculator would tell you, wait a minute, that doesn't work. You can't do that. So don't write no solution, because this little piece has no solution, but overall, x equals 2 is still an answer.
Okay.
So common factor, factor it out, and then set up two equations. Let's look at 28. I think there's several things we could do before we even get to new type stuff. Allie, what do you want to do first on 28?
Add 6.
Perfect. Kennedy, what do you want to do after we add the 6? Divide by 4. Let's see if I can not mess this up. So add 6, I get 23. Divide by 4, well, it's just 23 over 4. Uh-oh. We are going to fishhook. Okay? Again, this worksheet we're starting to jump around a little bit. They're not all exactly the same thing. Go ahead, Ryan. So e to the 23 over 4 equals 2x. So e to the 23 over 4 looks weird, but Aaliyah, if I have 2x equals something, what would I do to get x by itself? Divide by 2. So I'm not worried about the weirdness on one side. I'm worried about getting x by itself. So e to the 23/4 over 2, whatever that is, e to the 23/4 all divided by 2. I guess careful with parentheses and divided by. Maybe if you want a fraction for that one to make it look better. If that makes you feel better about things. 157.095. And I'm kind of tired of checking, but again, take that, plug it back in, and you should be able to convince yourself that you got the right answer. Yes, sir?
Number 30.
Uh-huh. Well, you got to 30 before I could tell you to omit 30. Because 30 is a little bit weird. If you factored out e to the x, you'd have two factors that equal 10, but that doesn't really do you any good. That only works for 0. So you'd need to move the 10 over and then factor what's left. We don't want to worry about that.
So 26.
And 31 is similar. Of course, we wouldn't have done 31 anyway, so you can mark that one off. So there's your hint on what type of factoring might be on the test. 27 versus number 30. Well, we marked out 30, and I starred 27, so I don't know if I can make it more obvious than that. 33. I think we're still using calculators, round answers to the nearest thousandth. So that looks weird, but I think we can handle that. Cole, what do you want to do first on 33? Add the 1. Luciana, what would we do next on 33? Okay. Yes. Let's do more than that, though. Yeah, it's divided by negative 8.9. So that will accomplish making it both positive and get the e to the n by itself. Okay, that was a lot of things. I probably should write a step down here. So add 1, that gets me to negative 6. E to the n equals 6 over 8.9. Let's just keep going with popsicle sticks here. Logan, what do you want to do next?
I don't know.
Okay. What's the problem with this problem, I guess? Where is that variable?
The exponent.
Yeah.
The log.
Perfect. Take the log of both sides so that it becomes a coefficient. That is exactly right. So now n comes out front. And we got another one where the natural log of e is just 1. Even if you forget that on a calculator problem, you could divide by natural log e and type it all in the calculator, but n equals natural log of 6 over 8.9. Negative 0.394. And once again, if you wanted to plug it in, it's a pretty easy plug-in to see if it works, but we'll just trust it. All right, on to 45. Quick check, is 45 a multiple of 3? It is. So again, I'm doing one of your problems for you. You're welcome. Or I apologize for taking your problem. Jackson, what do you think? What should we do first? Add 8. I like it. Negative 5 e to the 5a minus 5 equals, you've got a calculator, but hopefully you could add 8 there without the calculator. Jack, what would you like to do next?
Divide by -5.
I like it. E to the 5a minus 5 equals, and again, I'm not going to go to the calculator till the very end. Like otherwise, I've got weird decimals that I'm having to write down and remember, or write all the decimals down, or keep them in the. Just save it for the end. What would you like to do next? Okay, there's sort of two options here. You could take the natural log of both sides. That would allow the 5a minus 5 to go out front. That's what we normally do. Nothing wrong with that.
Could you set the 5a minus 5 equal to?
I mean, that's what's going to end up happening. 5a minus 5 is going to equal natural log of this.
Well, you'd have the natural log of it.
There's one other thing, though, that if we're really paying attention, we might catch. Jack, I think you're about to say it.
Give me the natural log of the negative.
We're about to take the natural log of a negative, which doesn't work. So this is going to be no solution. So if your brain is really engaged, you might catch it and be like, wait a minute, e to something equals negative? That's going to be no solution. Now you're right. If you go the kind of the long way, it's fine. Your calculator is going to tell you that doesn't work. But you may do a few more steps before you figure that out, because you would be doing natural log 70.6 divided by negative 5, and then you would add 5, and then you divide all that by 5, and it doesn't work because you tried to take the log of a negative number. So, hopefully you're paying enough attention where you catch it early. Most of the time, even good students don't always do that because they're kind of locked in on follow the process, follow the steps, log both sides, move things around. But eventually, hopefully you'll land at no solution. So it's just an example of there's times where no solution is an okay answer. Sometimes you can catch it early. Other times, if you're not really paying attention, you're just kind of focused on follow the process, you might not get it till the end. And that's okay as well. Okay, the rest of it is old stuff. Or at least once you get to like 62, it's just expand and condense and other solving problems. So I think that's all the ones I want to do. Again, it's multiples of 3, so you'll be okay. Yeah, it's a big waste of paper. That's fine. That's fair. It's not kind to the forest this 9 weeks.
Imagine Polaris would say, on 12, can you just put the 3 back?
Back to number 12.
Yeah, I didn't
Yeah, that's a great plan. On number 12, put the 3 back as the exponent. 2 cubed is 8. And if log base 5 of x equals log base 5 of 8, again, you don't really even have to know logs to realize the only way that's going to work is if x equals 8. Alright, so the only new thing today is log both sides if you need to get the variable out of the exponent. And a lot of this is also review. And only one more day of new stuff now.